Cheap and easily customizable 3D printed devices are perfect for assistive technology like prosthetics or smart pill bottles that can help patients remember to take their daily medications. But these plastic parts don't have electronics, which means they can't monitor how patients are using them. Now, engineers at the University of Washington have developed 3D printed devices that can track and store their own use without using batteries or electronics. Instead, these systems use a method called backscatter, through which a device can share information by reflecting signals that have been transmitted to it with an antenna. Previously, the team developed the first 3D printed objects that connect to Wi-Fi without electronics. These purely plastic devices can measure if a detergent bottle is running low and then automatically order more online. The researchers tackled the monitoring problem first. In their previous study, their system tracks movement in one direction, which works well for monitoring, say, laundry detergent levels or measuring wind or water speed. But now they needed to make objects that could monitor bidirectional motion, like the opening and closing of a pill bottle. Both of the antennas are identical, so the team had to devise a way to decode which direction the cap was moving. The gear's teeth have a specific sequencing that encodes a message. It's kind of like Morse code. So when you turn the cap in one direction, you see the message going forward. But when you turn the cap in the other direction, you get a reverse message. In addition to tracking, for example, pill bottle cap movement, the same method can be used to monitor, say, how people use prosthetics. The researchers also wanted to create a 3D printed object that could store its usage information while out of Wi-Fi range. For this application, they chose an insulin pen that could monitor its use and then signal when it was getting low. This method requires a mechanical motion, like the pressing of a button, and stores that information by rolling up a spring inside a ratchet that can only move in one direction. Each time someone pushes the button, the spring gets tighter. It can't unwind until the user releases the ratchet, hopefully when it's in range of the backscatter sensor. Then, as the spring unwinds, it moves a gear that triggers a switch to contact an antenna repeatedly as the gear turns. Each contact is counted to determine how many times the user pressed the button. All right, it's kind of complicated, but in another sense, it's fairly simple too. These devices are only prototypes at the moment to show that it is possible for 3D printed materials to sense bidirectional movement and then store that data. The next challenge will be to take these concepts and shrink them down so that they can be embedded in real pill bottles, prosthetics, and insulin pens.